let's see. Let's get going. I will share. Okay. So can you guys see my my board, right? My whiteboard? Okay, cool.
Yep.
Okay, so I'm gonna do 19, 20, and 21 on assignment number 7. Sorry, that was sloppy. Just because I had a few questions on that one, and it is a tricky one. This one is always kind of that like trick question, but we're gonna do it together. Okay, so it says you are cruising on a compass, or number 19. We'll do number 19. You're cruising on a compass course of 118 PSC, and you wish to return to your point of departure. What should the compass course be? Wait, what compass course should you steer on the return leg? Okay, so you are cruising. Let's see here. You're cruising at 118 PSC. And then I want to know what is going to be the return leg. What is the opposite of that? So in order to figure this out, I need to convert my compass to true and then apply my turn or my change of course to the true and then go back to compass. So we're going to go to true and then apply and then back to compass. So it's kind of this tedious exercise here, but it is practicing our compass error. So I've written out my TVMDC. Going down, add west minus east. Going up, we're adding east, subtracting west. So I am going up on this one. And I need my deviation. So I'm going to use my 118 PSC to find my deviation. Anybody get it?
Or east.
Or east.
Or
Yeah.
east.
Yes. 4 east. Okay. 4 degrees east. And I'm going up, so I'm going to be adding that. So I get 122 degrees magnetic. And then my variation, it told me that for these questions, my variation was 14 degrees east. So again, that's east. I'm going to add it. So 122 plus 14 is going to be 136 degrees true. So this line is 136 degrees true. And now I want to go on my return leg. So I'm going to apply 180 degrees to find the reciprocal. So my 136 plus 180 I can't do that one in my head here. So 136 plus 180 gives me 316 degrees true. So now I want to go 316 degrees true, and I'm going down to find what compass course I should steer. So then I'm going to have 14 degrees east, and going down, I am adding west, subtracting east. So I'm going to subtract my 14 to get 302. Then I'm going to go to my deviation table for 302. Magnetic heading. 302 is going to give me 5 west. Going down, I'm going to add that west. So I get a compass course of 307 degrees PSC. Did that make sense? We're going to apply the turn to our true so that we eliminate those errors, those deviation and variation. We apply our turn, because we want to return on the same leg, and then apply those errors again to figure out our compass course.
Is there a reason you don't stop just at the magnetic, since the variation's the same no matter what direction you're going?
That these kind of cancel each other out, essentially. I guess I just like to follow through with my formula and apply what we're doing to the true. That we're doing everything on the chart is true. Everything we take the chart will be in true, and when we're trying to find a return leg, that's in true. So I get that that would kind of be a shortcut there, but I don't know. I like to go with true.
Hey, Bree, can I ask a question?
Yeah.
What does deviation change with heading?
Why?
Yeah. I mean, variation is always variation. So why does deviation depend on your heading?
That's a good question. I feel like I wish I had a better answer. I always get this question. That we have our deviation or our compass on board, right, is floating around, and depending on where the pole is to the compass, that's going to be, I guess we can just say, we'll use a regular book. If our compass is right here, then, and like this is our big force, I guess, our magnetic force. If we're headed this way, it might pull it in a different direction. I don't have a good answer for you. I've talked around this answer a few times, but I always feel like it's not a good answer.
Hey, Bree, when you just demoed that, why is the magnetic force at the stern?
It could be anywhere.
Oh, okay.
It could be anywhere.
So I think I understand. So your mag compass, I mean, let's say you're on a big container ship and somebody
Yeah.
has a container full of magnets in the back and it's off center. So your heading is going to be, so your deviation is going to change because of the location of the different magnetic elements that are on the ship.
Yes. It's the magnetic elements that are on the ship that are affecting your deviation. And
Right.
That's why your deviation is based on your heading, not the bearing that you're taking. But I'm really not great at explaining that.
I have a question as far as like the practical application of this when you're on your own boat.
Mm-hmm.
Should we be like hiring somebody to come up with a chart for us to use on our own boat, or like how do we figure that out for our own circumstances?
I want to say practically most people don't account for deviation.
Okay.
I think you should, and it can be very, depending on what deviation could possibly be, it could affect your vessel more dramatically than not. There's always quick ways. You don't have to like completely swing the ship as getting like 8 to 12 bearings in one position to create that table, but it could be a good thing just to check if you get a visual range on an object or something, or on two objects, just to check what your deviation was at that moment in time and just put it in the logbook. And then if you're entering another port, check the deviation and enter it in the logbook. You don't have to do like a full deviation table, just so you can kind of see a trend maybe. I'm pretty sure you can hire people to create your deviation table. That's what we do in the commercial world. So I'm sure you could do it in the recreational world. I'm just not as experienced with that. If you come out of a shipyard, that might be on the kind of the sign-offs to turn the keys back over to you, is that they'll include a deviation table, especially if they've reconfigured the engines or added something significant. But I don't know, any input from the class on practical use of deviation tables in your guys' experience?
Well, I just want to share that the book has Appendix 3 and 4 where you can actually look and how to a step-by-step on how to actually do it yourself. It's something I was going to do, but I don't think it was that relevant for what I do in the recreational boating. I can see why if you're in a big container or commercial ship, you may need it. But I mean, just where I'm at, I really don't think it's going to make a huge difference.
I feel like that's what a lot of people's opinions are. It's great to have one. And again, maybe if you don't get 8 to 12 bearings, but maybe 4 bearings, and kind of create a rough deviation table, that would be great. I'm sure there's a bunch of YouTube videos out there on how to create a deviation table, like Robert said, step by step in the book, or you could contact me later. I kind of went over it on that slide really quickly, but yeah, I know it's a weird thing.
So can I ask a question on variation?
Yes.
Okay, so Lisa Beasley and I were talking about this last weekend. So all of our problems have been in the Northern Hemisphere, and we have variation, based on our compass rose and stuff. As you get closer, when you move into the Southern Hemisphere, let's say you're in Tasmania, is there any differences? I mean, are you still using north variations, or is it different in the Southern Hemisphere?
It is not different in the Southern Hemisphere. You're still going to be in between some variation lines. So you're going to have that plus east or west variation.
Right.
And everything is, relative to the North Pole, even though the people who are navigating in the Southern Hemisphere, their north is still at the top of the chart. They don't put the South Pole at the top of the chart.
Okay, thanks.
Okay, I'm going to do number 20, and then we're going to dive into this. Okay. So I had T, B. Okay. What is that black one? So number 20 said you are holding a true course of 192 degrees, and you wish to change course 90 degrees to the left. So change course 90 degrees to port. What will the new compass course, what will be your new compass course? Okay, so I am heading in the direction of 192 degrees true, and I want to turn to port 90 degrees. So am I going to be adding or subtracting that?
Subtracting.
Subtracting. So I want to come to 102 degrees true, coming to port. So I'm going to change my true to 102 and figure out what my deviation or what my compass is. So variation, we're still using 14 degrees east, and I am going down my formula, so I'm following these rules. So I'm going to subtract east, and 102 minus 14 gives me 88 degrees magnetic. I'm going to go to the table and find 88 degrees. I get 6 east. I'm going to subtract, and then I get 0.82 degrees PSC. So we're applying our turn or a change of course to true. That's the key to do those ones. Okay. I'm going to skip 21 just so we could dive into our PowerPoint and get to our plotting before the end of class. Let's see. Any other questions before we dive into PowerPoint? Okay. Well, today we are going to be focused on speed, distance, and time. So those are things we actually think about in everyday life, but we're going to bring it to the nautical and maritime and use those terms. And then we're going to get into a little bit of plotting and what we call dead reckoning. And another big thing for today is going to be adding and subtracting time, which can seem very elementary, but it is actually kind of a shift of the mind. We like to do things in tenths, but how we were adding and subtracting degrees and minutes, adding and subtracting time to hours and minutes is also, you just have to kind of rethink about how we do our math. But yeah, let's get started. We did this, and then I have to do display settings. No, shoot. Did it wrong again. Sorry, guys. Hold on.
I have a silly question because I always try to understand the concept of things. It's kind of a dumb question. Why are nautical miles different than regular miles? They're accounting for the curvature of the earth, obviously.
Okay, so hold on a second. I'm trying to, hold on. Duplicate, no. Okay. Keep changes. Okay. Share screen. Can you guys see the PowerPoint? Yes? Okay, cool.
Yeah.
Figured it out. Success. Okay. So I don't know where they came up with the statute mile, but the nautical mile is that 1/60th of a degree. And there's, 90 degrees of latitude in the northern hemisphere, 90 degrees of latitude in the second. So 1 degree of latitude has 60 nautical miles. And that's where they came up with nautical miles. Someone along the way came up with statute miles. I don't know the history behind that one, if anybody does.
Bree, nautical miles is a universal measurement, correct?
Correct. Yes.
Yeah, where the other one
I
is,
mean, it's almost like differences in currency. You know, it's like they just happen to be called miles, but they're really different. I mean, a nautical mile is a degree of arc, whereas a statute mile is something completely different. It's almost like an American dollar versus somebody else's dollar. They're just different. They just happen to be named the same, but they're not the same. A nautical mile is simply a degree of arc around a great circle, whereas
Right.
a statute mile is some arbitrary measurement that somebody came up with that just happens to call it a mile.
Right.
Yeah,
It was like Romans, actually. Roman time.
Romans.
Hmm. It
So,
was
yeah, there's
measured
like-
by 5,000 Roman feet was 1 mile, which turned out to be like Old English 1,500 or 8 furlongs. I think that's the history. And then even now to this day, it has a funny history. Like the German foot was a little shorter, but it's supposed to be equal to something along the lines of about 5,000 feet.
Yes. So there's all these different units of measurements, right? We have centimeters, inches, all these different cultures have come up with a different way of measuring distance. But nautical miles is universal. It is global because it's based on, there's 60 nautical miles in 1 degree of latitude. And we could base latitude, longitude and latitude is universal.
And it's
Yeah, so essentially people in Europe that use kilometers wouldn't really, it's a completely different currency. So if someone in Europe would just say, what's the difference between a nautical mile and a kilometer? They wouldn't get confused, but we get confused because they're both called miles.
Yes.
and it's just a coincidence they're close.
Yes, they are close, but they're not the same. Let's find our numbers here. Okay. Excuse me. Okay, so we're going to talk about speed, distance, and time and how they are all related to one another. So first we're going to talk about units because I like units of things. I am a formula person, so I like units, but I know not everybody is. But we're going to talk about units. So distance, we use a nautical mile, right? We just talked about that. So 1 nautical mile is 6,076 feet. 1 statute mile is 5,280 feet. So our nautical mile is longer than a statute mile. And a nautical mile is, that 60th of a degree of latitude. Statute mile, that's what you would use, on the highway. That's what we use on land in America. We use statute miles as our distance reference, but on the water, we use nautical miles. When we use time in our navigating, we're going to use hours or minutes. We like to say things also in that military time or universal or 24-hour, lots of different terms for that. So you could say, like, right now it's 1902. Instead of saying 7:02 p.m., we say it as 1902 or something like that. But when we put it into a formula, when we use our speed, distance, time formula, it has to either be hours or minutes. It can't be both. So if you're saying, I want to go this distance in an hour and a half, I can't use, 1 hour, 30 minutes. I have to either use 90 minutes or 1.5 hours. You have to go all hours or all minutes. It can't be both. And I'm going to show you the way to do both of them. Most in this class and most recreational boaters move everything to minutes. I'm going to go into that a little bit later, but think about it for time, either in hours or minutes, not combination. For speed, we use the term knots, which is nautical miles per hour. So it's just think about it like your MPH. If you're doing 60 miles an hour on the highway, it's nautical miles. So if you're doing 5 knots, you're doing 5 nautical miles per hour. You just shorten those nautical miles per hour into knots. So those are our units. And these are our formulas. Distance equals speed times time. That is going to be our basic formula, D equals ST. And that's if we have our T in hours. That's what the unit would be to follow that formula. However, we're going to use 60 times D equals speed times time and put the time in minutes. So I'm going to reference that as 60 D Street. That's 60 times D equals S times T, 60 D Street. And that's the formula that we're going to be using most of the time. And with any formula, you can rearrange it for the desired unit that you're looking for. So if I am traveling at 5 knots for 2 hours, how far would I go? 5 knots at 2 hours. You would just times your 5 times your 2, and you get 10. So 10 nautical miles. So you can think about that as if you're, on the freeway. If you're, traveling down to San Diego or something, and like, okay, I'm going to go about 60 miles an hour. It's going to take me 2 hours to get there. It's about 120 miles away. Right? We kind of do that math when we're, I guess most now our phone just plugs in our ETA, right? And you just like share your ETA. But I don't know, think back to, I don't know, however long ago. that we would say, oh, it's so many miles away. Okay, it's so many hours away. That we could do that math kind of in our heads. Okay, so we're going to talk about rearranging the formula. Now, this is going to go back to our arithmetic days of rearranging a formula and how we do that. So how to rearrange a formula is by rebalancing. I think there's a different math term for that, but you basically, if you do something to one side of the equation, you have to do the same thing to the other side of the equation. Now, when I say side of the equation, that means side of the equal sign. So if I do something to one side of the equal sign, I have to do the same thing to the other side. So this is an example. I'm looking for speed. So I want to get that S all by itself. So somehow I need to move that T over to the other side of the formula so I get S all by itself because I'm looking for speed. So I can divide both sides by T, and these T's cancel each other out. Dividing a T by another T, just like 5 over 5 is equal to 1. It's equal to just 1. So that cancels each other out. So the T's cancel each other out, and then we are left with 60 times D divided by T equals S. So we can rearrange a formula to any way we want. This is going to be it for doing time. If we want T by itself, we divide both sides by S, and we get the formula for time. If we want D by itself, we divide both sides by 60, and we get the formula for distance. Distance equals speed times time over 60. So you could write down each 3 of these formulas. D equals S times T over 60, and then 60 or T and what S equals. Or you could just remember the 60D street and then rearrange the equation each time instead of trying to remember 3 different equations. And if you don't like equations, here's the slide for you. Magic circle. Some people call it the magic triangle, but we use 60D street, so we call it the magic circle. It is magical. So our magic circle, we create a circle and we put a little quadrants in it, if you will. And we have 60 and D at the top and an S and a T on the bottom. How the magic circle works is we always multiply across, and then we divide by the leftover number, whichever one is missing. So if we're missing T, we multiply the D and the D and the S, excuse me, the 60 and the D, and then we divide by the missing one. If we're missing D, we multiply these 2 and then divide by 60. So if you're into equations, sometimes the magic circle is confusing. If you're not into equations, sometimes the magic circle works. I like to introduce both because we have a variety of people in our class and everybody's mind works differently. So we're working with whatever you can work with. So I will go back and forth when I do my examples of using the magic circle or 60D street. And if you're using one or the other and I do a different one, just holler out, hey, can you do it using 60D street? Or hey, can you use it doing the magic circle? And I'd be happy to. Let's look at an example. Okay, so here's an example. We have a speed of 15 knots and a time of 30 minutes. How far did I travel? I'm going 15 knots in 30 minutes. How far did I travel? If I'm using 60D Street, I want D, because that's said, how far did I travel? I want D all by itself. So I'm going to divide both sides by 60. The 60s cancel out, and I get the formula for distance. Then I just plug in my numbers. S equals 15, T equals 30, divide by 60, and I get 7.5 nautical miles. Now, if you're doing that using the magic circle, you plug in your numbers. So we have 60 and a question mark, and then a 15 and a 30. We're going to multiply what we have. We have two things, our missing value here is D. So the two things that we have next to each other, we're going to multiply. So we multiply 15 times 30, and then we divide by the one that we're missing, which would be the D. So 60, we divide by 60, and we get 7.5. Let's try another one. We are looking for time in this case. So I'm traveling at 8 knots. I need to go 2 miles. How long is that going to take me? I want T all by itself. How long is that going to take me? So I've rearranged my formula to get T all by itself. And then I just plug in my numbers. 60 times 2 divided by 8. I get 15 minutes. It'll take me 15 minutes. Magic circle, we plug in our numbers, we multiply the two that we have, and then we divide by our last one. Okay, now we're going to do a speed. We're going to do all three. We're looking for speed. All right, so we are traveling 5 nautical miles. We need to get there in 45 minutes. How fast do I need to go? So I need to travel 5 nautical miles in 45 minutes. How fast do I need to get there? So we make S all by itself, rearrange our formula. So we plug in our numbers. 60 times distance, which would be 5, divided by 45 gives us 6.7 knots. If we're using the magic circle, the two things that we have are on the top, so we multiply those, and then we divide what's left over on the bottom. So for a magic circle, the two things that are next to each other, we multiply, and then we divide by the leftover number. Okay. Questions on formulas?
I like the circle because that horizontal line is automatically your dividing line.
Yes, but sometimes you're multiplying the bottom and then dividing by the top.
Right, but either way, it acts as your dividing line, which I like.
Okay. Cool. Okay. No questions. Okay. So let's keep going. Ooh. Okay, where do we find this information? Sometimes in the question, it's not going to say exactly what I did in these examples, as in the distance is this, the time is this, the speed is that, blah, 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 blah. So sometimes we have to think about it. So sometimes it's you're at buoy A and you're going to light B or whatever it is. So the distance is measured on the chart. So if it doesn't say in a question, you're on such and such course for 5 miles, you might be at, Newport and you're traveling to Dana Point. What is the distance? didn't give you the distance in the question, you just need to measure it on the chart. It can also be given to you in different ways, nautical miles, yards, meters. And in our formula, we use nautical miles. So I'm going to say everything in this class is going to be in nautical miles. But sometimes when you get closer to something, it'll your GPS or whatever unit you're using will switch to meters as you're getting closer to something. Like on your phone, right? It goes from you're going to make a right-hand turn in a half a mile to you're going to make a right-hand turn in 500 feet, 200 feet. It changes, right? So depending on what type of unit you're looking at, it might give it to you in a different thing. So just be aware of the units. And if we're using our 60D street, it's in nautical miles. Okay, or time, hours or minutes. Remember, it must be in hours or minutes, and we have to convert it to hours or minutes, and that's what we're going to work on next. Speed is always going to be in knots, and we use our speed, right? S equals nautical miles per hour. Speed equals D over T, nautical miles per hour. That's what a knot is. Okay. So let's practice converting time. I didn't do this one? Okay. So we have an hour and 15 minutes. So if we are looking at converting to whole hours, as in hours, we don't have any minutes left over here, we would say it's 1 hour and 15/60ths of an hour. So we would divide 15 by 60, right? Because there's 60 minutes in an hour. So 1 hour and 15 minutes would be equal to 1.25 hours. Or we can convert it to minutes. It would be 1 hour, 60 minutes, plus the 15 minutes would equal 75 minutes. So both 1.25 hours or 75 minutes, right? We can use either one of those. So depending on what you're more comfortable with, I say use that. And I'm just gonna say, most people are more comfortable with the minutes. It's when you get into bigger numbers, like 6 hours, 36 minutes, is when we get into something that isn't easily as convertible in your head. Like 75 minutes, you could say, oh, that's a little over an hour, right? 60 minutes is an hour, 75 minutes, 15 minutes over that. Where we get a big number, like 6 hours and 36 minutes, if we want to change that to hours, we would change 6 to, and then have 36/60ths. So that would be 6.6 hours. Or we have our 60 minutes times 6 hours plus the 36 minutes. And we get 396 minutes. So if I throw out there 396 minutes or 6.6 hours, it's easier to, I guess for me, not for everybody, easier to kind of think about that like, oh, I'm going 20 miles per hour at 6.6 hours. Okay, how long is it going to take me to maybe quickly kind of do those math where I have 396 minutes, I can't even like comprehend that number, how many minutes that is. It's a little bit harder to really process. I guess I'll do this next example and then I'll make my point here. Okay, if you have 42 minutes If I converted it to hours, it would be 42/60th, so I have 0.07 hours. Or if I just leave it as minutes, really straightforward, it's just 42 minutes. So again, we have to do either hours or minutes. Typically in the recreational small distances that we're going to be going around Southern California here, we just put everything into minutes. If you are traveling to Hawaii from Newport, you're going to be traveling, I don't even know, like 20,000 minutes, which is just not a comprehensible number, versus, you know, I don't know, 48 hours. Oh, that's going to be 2 days. Or 50 hours. Okay, that's a little over 2 days. So the hours are more easily converted in your head over long distances, and that's more used in the commercial world. In the recreational world, we're doing, you know, afternoon or day trips where it's much smaller scale, I guess I'm going to say. So we do things more on the minute side. So we're going to be converting everything to minutes. But again, if you were doing something very far and very long, that minute number can be just crazy, right? So I guess I don't know what I'm saying here. What else point did I want to make? You could kind of see here on my bottom two examples that they are multiples of 6. In my world, we do a lot of things on the multiple of 6. That way we have everything ends in a tenth of an hour, and it's really easy to do ETAs and consumption problems and reports that way. So even if we like left at, I don't know, 7:38, we would say we left at 7:36, so it would be even on our fuel consumption, essentially. But anyways, we're going to use minutes in this class. Long story short, we're going to use minutes in this class. Sorry. Let's take a quick breather. I need to take a quick breather. I guess I'm rambling. Can we come back in 5 minutes? Let's come back at 7:30. Okay, cool. All right. Well, let's keep working on our math. I'm not a math teacher. My sister's a math teacher. Billy, I think, is a math teacher. A lot of math people out there. But bear with me on my math teaching abilities. Okay, so our next step into this topic is adding and subtracting time. And we're going to be adding and subtracting, you know, hours and minutes to a certain time, or the differences between 2 times to get an ETA or a time elapsed. We're going to be adding and subtracting time, essentially. So, and again, we're using this military or 24-hour time, where has anyone not experienced 24-hour time? You just have 1 through 24 hours instead of having an AM or PM. So essentially, if you have, you know, a number bigger than 12, you can just subtract 12 and click it back to an AM or PM, if that's the way you want to look at it. I don't know. My husband and I both have worked on ships for so long that our clocks around our house are on 24-hour time now. So it just, makes sense to me. Like I know what 2200 is or whatever. But I know a lot of people can't do it or have to process it back to an AM PM time for it to make sense to them. But in our adding and subtracting of time, we are going to be using the 24-hour time format. Okay, so when we are adding and subtracting time, just like if we were adding and subtracting a 4-digit number, we're going to start on the right-hand side. We're going to start on the minutes. So we always start with the smallest unit. If it's minutes, we start with minutes. If there are seconds involved, then we start with the seconds. We start with the small unit. So I like to put a little line through my equation, and you'll see me doing this, where I have my minutes on one side and my hours on the other. So then I subtract, or in this case, I'm adding 23 minutes and 12 minutes. I do the minute section first, and then it's easier to carry or borrow if you're doing the minute sections and then the hour sections. If you are subtracting, you always want to put the later time on top.
Are we supposed to be looking at the PowerPoint or?
Yeah, I was gonna say, can you share your screen? We don't see the.
Oh my gosh, I'm sorry. I'm like moving things around. Can you see it?
Awesome, yeah.
Okay, I'm so sorry about that. Oh, just me going on here. You guys can't even see what I'm talking about. Okay. Okay. So yes, here's me putting a little line in between the minutes and the hours. Again, all of these times are in the 24-hour time. You have the hours and minutes, right? And I put a little line in between hours and minutes so I can visually see that I'm going to do minutes first and then I'm going to do hours. If we are subtracting, we put the later time on top. A lot of people want to do it chronologically, but they have a smaller time on top. But if you're subtracting, you always want to put the later time on top. Even if it's going to be, the next day later, I think we're going to have an example of one of those. But the later time on top, especially when we are subtracting. Okay, so here's some examples. We have 11:23 and 10:12. We're going to be adding. So we do the minutes first. So we're just going to add the 23 and 12. We get 35. And then we're going to add the hours. Pretty straightforward. Subtracting. Again, I put that little line and I do the minutes first. So if I had departed here, arrived here, how long did it take us? I need to subtract these times. So I'm going to start with the minutes, and I have 55 minus 35. Got 20 minutes. 22 minus 20, I get 2 hours. So the difference between these two times are 2 hours, 20 minutes. Here's adding, we departed at this time, and we want to, and it's going to take us 1 hour and 25 minutes. I always put my little line and do the minutes first. In this case, I get 70 minutes, 45 plus 25. But I can't have 70 minutes in a time, right? It goes to 60 minutes and then starts over again. So I need to carry over the 60 minutes as a 1 on the hour side. So that 70 minutes turns into 10. I subtracted 60 and I carried over a 1 hour. So on the minute side, I subtracted 60 minutes and then I carried over a 1 hour. And I'm going to add those up and I get 1710. So 1 hour and 25 minutes plus 1545 will give me 1710. Okay, now let's look at subtracting. Again, I always put my line down, and I have the difference between 912 and 823. Again, the later time is on top, and I want to start with my minutes. So I have 12 minus 23, but I can't do that because 23 is bigger than 12. So I need to borrow from the hour side. So I'm going to borrow an hour, and I get 8 hours and 72 minutes. So that's 60 plus the 12 gives me 72. So I have 8 hours and 72 minutes. Then I'm going to be able to subtract my 72 minus 23 to give me 49. And then I have 8 minus 8 is 0. So I'm just left with 49 minutes difference between these two times. So those are going to be our basics on adding and subtracting time. Does anybody have any questions on how I did that? So we want to remember to do the smaller unit first, the minutes or the seconds, and then work our way over to hours or days. So now I'm going to put this up here for 5 minutes or so and have you guys work on this. Top one is getting ETAs. So we have a departure time, a transit time, and when will we arrive? And then we have a difference between times. So what is our transit time? If we departed at a certain time and arrived at a certain time, how long were we transiting? And then our last one is, when should we depart? If I have a desired ETA at a certain time, I know it's going to take me so long, when do I need to depart by? So go ahead and work on those.
Bree, can I ask a quick question?
Yeah, go ahead.
I get the math, ran through and got the answers, but that dash between, like, let's say, for example, on the first one there, or on the second problem on the top line with the ETAs, this dash ahead of the 42. What's the significance of this again? And will we expect to see that like on the U.S. Sailing charting exam? Will it be in that same fashion?
I'm going to say no, that dash is the shorthand that I use.
Mm-hmm.
I really try to avoid the dot dot. A lot of people really like to do hours and minutes with a dot dot. But that is very confusing when you're looking at time, and the 24-hour time does not have, you know, that those two dots that us as Americans we like to use.
Mm-hmm.
So I would say typically on a test you'd see the H and the M as for hours and minutes, but my shorthand is a little dash.
All good. Thank you very much. I appreciate that clarification.
Okay, Billy was talking about calculators and how his calculators does fractions. Again, it's just how familiar you are with your tools. If you're testing U.S. Coast Guard exam and you're testing at the exam center, the REC, you can use the TI-30. That's this guy. That's the approved calculator for testing. Again, if you're testing at different school, they pretty much don't have an approved calculator. But on this one, you can do degrees, minutes, and seconds, and hours and minutes. You just have to figure out how to do that and be comfortable with it. I don't know. There's all sorts of cool things you can do out there. I'm sure there's a different app if you have an app for it. But for those of you testing, you're obviously aren't allowed to use your phones or iPads or whatever during testing.
But do they have a restriction on calculators? Like they wouldn't let you bring a graphing calculator like a TI-84 or something like that?
Correct. Yes. The only calculator you're allowed to have or they issue you for Coast Guard exams is this one.
What about at the school?
I'm going to say they don't care at the school.
Okay.
Because that's the one I used for 20 years, but now that new one, it's funny, I just started using it recently and like, oh, this is so much, it's still the same thing, but it's just easier to use. That's like I said, it sounds funny, the TI-36X Pro, but that's actually it's a cheap little one.
Yeah.
It does work.
So I think in reverse Polish, can I not use an HP calculator?
Classic.
Okay, I will click through here. Okay, I clicked through my answers there. Another thing, speaking on calculators, I think it's good to learn how to do it by hand like we're doing now. And like when I'm teaching my celestial class, we do things by hand. So that way, when you start using a calculator with degrees and minutes, or you start using a celestial calculator and you get like some wacky number, you kind of like can say, oh, I probably did this or did that. That if you know how to do it longhand, then you could trust the number more than, I don't know, maybe I'm rambling. Yeah, it's a rambling night for me. Sorry.
This used to be a 6th grade math standard, and it was just brutal to teach this in 6th grade. There was so many numbers. It's one of the toughest things ever.
Yeah. 6th grade math standard. Interesting.
Back in the day, yeah. Now,
Yeah.
When I was doing sailing into science, speed, distance, time was a 5th grade curriculum.
Well, we like to relearn it, and sometimes it's hard to teach an old dog new tricks. In my experience of maritime teaching, it's people who have not been in school for many, many years.
Well, I appreciate going through the process of understanding it without the calculator.
Yeah.
Because it actually drives me nuts to just have to memorize processes. It's much better for me to understand how it works, because then I can remember which process to apply at the time. But I'm too old to memorize stuff anymore like that. So I have to.
For sure. We'll get. Okay. Did anybody have any questions on this? I didn't quite walk through it. Again, we had the last question on here. We had, we went to a different day, the day before. so you can see my work.
Hey, Bree, this is the one who's bad at math. For some reason, I'm having trouble with the middle formula on ETDs.
Okay. So, oops. The middle one here, we have 1400. We want to arrive by 1400, and we know it's going to take us 36 minutes to get there. So, so this is a subtraction problem. I put my line down the middle, and then I have 0 minus 36, but I can't do that. So I need to borrow an hour. So I'm going to change that 14 to a 13, and then I get 60 minutes on the minute side. So 1400, 1400 is kind of equal to our 1360. We just have it in a different format. So then now we could subtract 60 minus 36. And that gives us 24. And then we have 13 minus 0 gives us 13. So we want to depart by 1324 to get us there by 1400.
Okay, so 1360 was the substitute for 14. That's what I didn't get. Okay, thank you.
Yeah. Okay, any other questions? You guys doing okay? All right, then let's go to our homework assignment.
Yes.
Assignment number 8. That's this guy. Only has 6 questions, so we're going to do it together real quick. Number 8. And we have number 1. So number 1, so they give us on our worksheet, they give us the formula 3 different times. Again, it's just that 60D Street formula rearranged. And then it kind of tells you everything needs to be in minutes, et cetera, et cetera. So we're going to start with number 1. And it says at 11.6 knots for 2 hours and 14 minutes, what is the distance traveled in nautical miles? So I'm going to put what I know. I know my speed is 11.6 knots. My time was 2 hours and 14 minutes. My distance is what I'm looking for. So that's the question. And now I need to figure out how to solve it. So what I know is I need to solve for D, but I also need my time in hours or minutes. So we're going to convert it to minutes. So I'm going to say, what does this equal? It's going to equal 60 plus 60 plus 24, 14. So that equals 134 minutes. And that is what T is. And I have S. Okay, so if I use 60 times D equals S times T, that's my 60D Street. I want to get D by itself. So I'm going to move my 60 over. And I get S times T divided by 60. And then I'm going to plug in my S and my T. So I get D equals 11.6 knots times 134 minutes divided by 60. I'm going to plug that into my calculator. 11.6 times 134 divided by 60. And I get a D of 25.9 nautical miles.
Do you round that up or no?
I say if you leave it as to the nearest tenth.
Okay.
That's for speed and nautical miles. Okay. If you were doing magic circle, there's my magic circle. So we have 60. D is what I'm looking for. S is 11.6. T was 134. So I'm going to multiply my 11.6 divide by 60. And I get my 25.9. Any questions on that? Okay, let's do number 2. It took 1 hour and 22 minutes. So I have a time of 1 hour, 22 minutes to cruise. That means a distance of 18.6 nautical miles. What was our speed? So I'm looking for speed. We cruised 18.6 nautical miles. It took us 1 hour and 22 minutes. How fast were we going? So I need to convert my time to minutes. So I have 60 plus 22 gives me 82 minutes. And now I can plug it into my formula. So I have 60D equals ST. I want my S all by itself. So I'm going to do 60 times D divided by T gives me S. 60 times distance, 18.6, divided by time, 82, gives me speed. If I'm doing 60 D Street magic circle, I have 60, 18.6, speed is my question mark, time was 82. So I'm going to multiply these and then divide by 82. What did you guys get for speed?
13.6.
13.6.
13.6. Okay. So this is a good time to practice doing one way or the other if you are unsure of which way you want to do it. But any questions? Let's keep going. Number 3. You cruise at, so we have a speed of 14.3 for a distance of 24.6. How much time did it take you? So I'm looking for time. So in this case, I don't need to convert my time yet because I don't have it. So we'll just go with our 60 D Street. We want time, so we'll do 60 D divided by S, gives us time. We'll plug in those numbers. To give us a time. If I am doing magic circle, question mark. What do you guys get for T?
103.2.
Okay, so we got 103 minutes. I'm gonna round it to the whole minute there.
Okay.
But now I need to convert 103 minutes to back to hours and minutes.
So it
So-
would be 1 hour and 43 minutes.
So I'm gonna subtract 60 and I get 43 minutes left. So that means I have 1 hour and 43 minutes. Now doing this conversion back, I guess there's more than 2 ways. I want to say there's 2 ways to do it. You can just keep subtracting 60 until you get a number smaller than 60. Or you can divide by 60. That's putting it back to hours essentially. So if you divide by 60, let's do it here. So 103 divided by 60 gives us 1.71667. If you subtract what's on the other side of the decimal, so I'm going to subtract the 1, and I'm just left with 0.71667. And then multiply that by 60, you put it back into minutes. 43. But again, there's lots of ways to convert minutes. What is there? There's like a conversion.
Why you cannot just subtract 60 from 103 and get 43 as a minutes?
Yes, you could definitely do that.
I think she's
But
trying to show another way.
If you get to where we had what was it in the slide, we had 396 minutes. You're going to be subtracting 60 a few times until you get something.
Just 6 times.
Just 6 times, yeah. Where if you divide by 60, you get 6 times a big number. So you just subtract that 6 and then multiply it back. But there's so many different ways to do it. So many people do it differently. Do which way works best for you. Just the subtracting 60 totally works. I would say doing the multiplying and dividing can get a little bit tricky. I guess if you're not imagining what number it is. But anyways.
So if you had like a big number like the 300 and you divided that by 60, wouldn't you just be able to from there figure out how many hours that would be? And then because like if it's a multiple of 60, 60, 120, 180, you just kind of go up there and then you can kind of figure it out that way.
Let's come up with a number. I'm trying to look for a number here. I'm using somebody's phone number that's on here. 789. So that's our number in minutes. I want to convert it to hours and minutes. If I was doing it the multiplying way, I could do 789 divided by 60. I get 13.15.
Perfect. So
that's hours, but that's 13.15. I would subtract my 13 and then multiply that back to minutes by 60 times 60, and I get 13 hours, 9 minutes.
okay, cool.
So it's easy to say, oh, that's 15 minutes. That's 0.15 of an hour.
Yeah, okay, but that's wrong because you have to multiply that by.
You have to bring it back to minutes.
Okay. Nice. Okay, thank you.
Okay. Let's skip to number 6. That way we can get to our DR and our chart plotting. Number 6. You're at a local harbor at 10. You want to cruise to a distant harbor to meet friends for lunch at 1300. Distance harbor is 19. So we have a distance of 19.8 nautical miles. The boat just came from shipyard, and you know that it will go a speed of 5.8 knots, no problem. Will you make it to lunch if you depart at 10 o'clock? Okay, so then we want to know what the time is. We have an ETD of 10 o'clock. Okay, so how long will it take us to get there? I do my magic circle, 60 DST. I have 60, 19.8, 5.8 equals time times 19.8 divided by 5.8 gives me a time of 200. We're going to go with 205 minutes. So you go 205, you can just minus 60, minus 60, minus 60, gives us 3 hours. Oops. 3 hours and 25 minutes. So if I depart at 10 and my transit time is 3 hours, 25 minutes, what is my ETA? So I like to put my line. I'm going to add my minutes first, 25, and then I'll add my hours, 13:25. So cocktails or lunch was at 1300. I'm not going to be able to make it in time. I need to go faster than that. That makes sense?
Could you please do that one the other way as well?
Yes.
The D Street way.
60 D Street. So we want time by itself. So we're going to do 60 times D divided by S equals T. Excuse me. we're going to plug in our D and our S. So 60 times 19.8 divided by 5.8 equals T. So 205 equals T. Excuse me. All right. So this is our math day. Can you guys see the PowerPoint? Okay, cool. Okay. So now we're going to see, now that we've mastered the math, right? Hopefully. We'll be practicing, don't worry. We are going to apply it to the chart. And so on our homework assignments, we did most of number 8. You could finish that. Number 9 is just practicing that 60D street. And then number 10 is on the chart, practicing DR plotting. So we're going to talk about what DR plotting is and work on our chart for the rest of the night. So we're going to, excuse me, we're going to be applying this 60D street rule to our chart. So what is dead reckoning? Has anybody heard of that before? DR, dead reckoning, deduced reckoning is what it really stands for. It's basically just a calculated position, and the calculation behind that position is 60D street, what we just talked about. So dead reckoning is only a calculated position. So we use it for a backup. So for our GPS or visual fix, if we can't get any of those, we can DR, and it's just purely calculated position. We also use it for predicting or projecting. So where am I going to be in an hour? If I'm on this course at this speed, where am I going to be in an hour? That's my projected or predicted position. And it's purely calculated, right? Because that's in the future. We don't know where we're actually going to be. But if I'm on this course, if I'm on this speed, and it's going to take me 60 minutes, then I can predict where I'm going to be by using the 60D street. So what do we need to know to plot a DR? So I'm going to call dead reckoning DR. So when you hear me say DR, that's what dead reckoning, that's what I'm referring to. So to get a dead reckoning position, you need to have a starting point. So you need a known position, and that position also needs to have a time. So you need to have a known starting point, whether it be I left the C buoy at noon or excuse me, somewhere along the line, you need to have a starting point. And then you need a course and a speed. So if I am maintaining 090 at a speed of 5 knots, where am I going to end up? And that's going to be my DR position. It's purely calculated. We aren't applying current. We aren't applying, swells. We're not applying the wind. We're not applying anything else. I got an LOP along the way or whatever it is. It's purely just a past position and course and speed. So we're creating this vector to predict where we think we're going to be. Or where we think we are, if we can't get a position because GPS is down or we don't have any aids to navigation to get a visual fix. So we're just going to plot a DR. Like, I don't know how, you know, where I am exactly because I don't have any visuals around me or my GPS is out, but I do know my average speed over the last hour has been 5 knots, and I know what course I've been steering. So I have a predicted position of where I think I should be. And then it can also go if, you know, I'm steering this course for this amount of time and my GPS says I'm 10 miles over there, something might be wrong. If I knew I was over here, that's a known position, and I only traveled for an hour at a certain course, and then my GPS says I'm somewhere crazy, something's wrong. You need to figure something out. I'm not going to say your GPS was wrong. Maybe your known position or your calculations were wrong. Something was wrong where you need to hove to and figure out where you actually are before getting yourself in any other danger. So dead reckoning. These are some basics on dead reckoning. We are going to label it with a semicircle. I don't even have, oh, there we go. So in this case, this 8 o'clock position is my DR position. I had a plot or a track line plotted. So I had waypoint 1, that's what WP is. That stands for waypoint. That's just kind of like a turn, if you will. So I had waypoint 1 with a track line to waypoint 2, and then a course and a speed to a buoy. So that's what I've plotted as my track. I got a fix at 7:30, and I was right there. At 8 o'clock, so where am I going to be at 8 o'clock? I guess oh, it says my speed was 12 miles. So 12 knots. So in a half an hour, I would go 6 nautical miles. I know I just did that in my head, but that just goes back to our 60D street of this is the course, this is the speed. In a half hour, where will I be? I'm going to be 6 miles away. So I use my dividers to say I'm 6 miles away along my track line, plot a DR position. The DR position is plotted with a semicircle, and then our time is at an angle. So it's not straight. It's kind of saying that this is a calculated position. I'm not going to say a guess because it's not just a guess. It is calculated, but it's only calculated using your course and time and speed. So sometimes your speed that you're using for your DR isn't exactly correct. Sometimes the course that you're using for your DR isn't exactly correct. So this is just purely calculated. If we were to go exactly 090 degrees true at 12 knots, that's where I'd be in a half hour. So when do we plot a DR? I think the book says every 30 minutes. I like to do one at the top of the hour and then either every hour or every 30 minutes from there. That way, you know, if you got a position at 7:42 and then you're doing DRs from 7:42 from there on out, it can just get confusing. So you just do one to 8 and then do every half hour after that. So you want it on a logical timeline, I guess. It's just easier to quickly give ETAs to people over the radio, to people on deck, when we're going to be passing this buoy, when we're going to be entering the jetty. If you have it plotted on the chart on every hour or half hour. So and I would say it also depends on where you are. If you are in a, you know, congested coastal waters, maybe you want to plot one every 15 minutes or every 6 minutes. Because things may be changing that quickly. If you're crossing an ocean, every hour is the standard. But again, that's going to be dependent on where you are. Then you also want to plot a new DR if any of your 3 things that you need changes. So if you change your course or you change your speed, that DR is going to change, right? So if we have a course change or we have a speed change at any time, we want to plot a new DR. Or if we fix our position. So we have a new known position, right? I'm going to go back to this slide where what do we need? We need a known position, a course, and a speed. So if we get a new known position, a new course, or a new speed at any time, we're going to replot our DR. So if you fix, yes?
Quick question. Obviously you would replot if you change speed, but how anal should one be about changing speed? Because knots are constantly variable. Like when you say change speed, at what point, minus or plus in knots, should I replot?
So that is going to be up to the navigator and what your situation is, right? So if you are, you know, in open water and you went from 10 knots to 9.5 knots, maybe that's not a big difference, so you don't have to replot. But if you're in, you know, congested waters, coastal waters, and you got like a gust of air or something, and you're going a knot faster than you thought you were, then you probably want to replot because you're going to be much further along your track line than you thought you'd be. So I know a lot of my answers are like, well, it depends, but it really does depend. What I give you here is just kind of like a rule of thumb baseline, and then we apply our in the moment navigating skills to adjust it one way or the other. So at the same time, you don't want to be, you know, down below changing your DRs for every half knot that your speed is fluctuating every 10 minutes, because then you're not, you know, looking out and navigating what's around you. So there's just this balance, and it's up to the navigator to figure out how, and they call it, you know, bridge team management or situational awareness. There's lots of different studies and things on really balancing all these different things all at once. So, you know, like navigating is just one little part of running the boat. There's like all sorts of other things involved too. So I don't think that's a very good answer to your question, but
no, that is a good answer. And obviously, you know, if you're racing, and then you've got a whole other situation. So I guess you just, you know, depending on what kind of sailing you're doing and where is the answer.
Yeah. Okay, sorry. Okay, these are symbols. I get questioned a lot about why I put these symbols there, so I put this slide in of, you know, proper etiquette of proper symbols. So this is, you know, by the book, how you're supposed to label each of your fixes. But again, it's, you know, who's looking at your chart on board. It's your crew. Does your crew understand what these symbols are? Or is it just going to be like, this is the crazy person doing all sorts of weird symbols on the chart? or, you know, it's really dependent on your crew and making, you know, communication even across the board. You want everyone to be able to understand what you're putting in the logbook, what you're putting on the chart, label it enough that you can label it or not, essentially. And I do have these in order here of kind of value or accuracy. So our dead reckoning fix is our base, is our most basic, least amount of information. All it has is a past position and a course and speed. And then we have a bow and beam fix, which we're going to go into on week 6. And then we have an estimated position, which is a DR plus one more piece of information. So that estimated position can be, we have our set and drift, you know, current, swell, whatever it may be, leeway, or we have one LOP. We don't have 2 LOPs. The running fix is we have 2 LOPs, but they're at different times. We didn't get them simultaneously. And we're going to go into running fixes again in week 6. And then we have electronic fix. So that's going to be our GPS and our radar. And then we have our visual fix. So we're saying that our visual fix is most accurate, that we are saying our eyes and our brain are more accurate than the electronic fix. Where I kind of want to say sometimes that electronic fix can be more accurate than our eyes, and you know, the human error of plotting a bearing using a handheld compass versus using electronic, as kind of, I'm going to call those two the same, but technically we're going to trust our visual fix over electronic fix. So just wanted to throw that in there, that really our dead reckoning, which is what we're going to do today, is that baseline. All it is a known position, and then it's purely calculated. So we're not having any other information involved in that. Any questions? Okay. Then let's take a break. This is the end of our PowerPoint. And let's get out our training chart. So is a 5-minute break okay with you guys? We have got an hour left here. Okay, so let's come back at yeah, 8:35. I guess it's a little bit more than 5 minutes. Come back at 8:35 and we will be working on assignment 10. So have assignment 10 out and the training chart. All right, see you in a minute.
Bree.
Yeah.
So talking about electronic versus visual, in my class with Captain Prelo, she was talking how they were over at Catalina and the Rock of Gibraltar, whatever, White Rock, one of the big rocks over there. The GPS showed them on top of the rock, but they were reality about 50 to 75 yards away from it.
Yeah.
So don't always trust that GPS, right?
Yes, yes, that you want to trust your eyes more than GPS for sure. And like in that instance, I would say, sorry, my dog is getting on my shirt. Like there's something, you know, in error with your GPS. So you need to get it calibrated or adjusted in some way.
Right. Okay.
So that getting positions and checking your, you know, visually or by radar or by whatever any other means, and then checking your GPS against it is a great way to make sure that they are in line. And that's an example of when they are not in line, and you would need to have someone come aboard and adjust whatever, maybe your antenna's off or whatever is going on. I am not a maritime electronic expert.
No problem.
We hire people to do that.
Exactly. Thank you.
Yeah. All right, well, let's get started. So we are on assignment number 10. So we are going to practice our plotting skills. So kind of a combination of what we've been doing. So we have at 8:20, you depart Brenton Reef. That's going to be over here. And it tells us the characteristics and the position to make sure we identify it correctly. And then it says we set a course for Buzzard's Light over here at a speed of 6.5 knots. It asks us what the true course is, and then asks us to label our course line with our DRs and our ETAs. So that's kind of what we're going to work on, kind of 1 through 5 here. We're kind of doing in a big step. So the first thing I'm going to do is create that track line. So I'm going to draw a line from Brenton Reef to Buzzards. So I have a long ruler that I'm going to use. Oops, and I already moved it. Okay. So I have my line, and then I want to figure out what that course line is. Oh, and I'm departing Brenton Reef at 08:20. Well, you can see that, 08:20. So I want to figure out what my course is. So I'm going to use my triangle, and then I'll show you how to do it on the parallel. But we have it crossing 2 verticals, so you could use any one. But I put the black line over and the focal point on the vertical line, and I read the bottom. I know you can't, I'm pretty zoomed out, so you can't see it all the way. Let me say a course of 096 degrees true. So if I was using a roll plotter, I have my compass right here. I'm going to line up my line on that black line. So that black line, I have the line, and then I'm just going to roll it down to my compass rose. And see what I get for my true course. So I get 096. If you're using your parallels, you can do the same thing. Walk it down to the compass rose. Draw your line, and you get 0.96.
Sorry, can you do it with the triangle one more time?
Yes. So I'm going to put the line and the focal point. So the line of my course on the black line on the edge of the triangle, and then a focal point on a vertical line. And then I'm going to read down here. I have 90 and 100, 110, etc. So I'm in between 90 and 100. And I'm looking, and I got one past the middle, so 0.95 or 0.96.
Okay, thank you.
Okay. So then I want to plot what my my DRs essentially. So I am going to, I guess first it asked me what's the total distance of this leg and what's my ETA at the end. So we'll do that first, I guess. My dividers won't stretch. So I am going to go to the side and get 5 nautical miles. So here I have 5 nautical miles. And then I'm going to walk that. So I start at Breton Reef. And I go 5, 10, 15. And then what I do here is measure just the end. So I have 15 plus, and I measure what this distance is. So 15 plus 1.2. So I have I'll say my distance on this leg was 16.2 nautical miles. That's going to be my total distance of the leg. Without doing my DRs, if I have a total distance of the leg being 16.2 and my speed is 6.5, what is going to be my ETA? I left here at 8:20. So I'm looking for time. So we have our 60D Street formula. We'll plug it in to get 60 times 16.2 divided by 6.5. And what is our time? $60 times 16.2 divided by 6.5 gives us, I'm going to round this, I'll just round this, yeah, to 150 minutes is my time. 150 minus 60 gives me 2 hours, 30 minutes. So if I had a departure time of 8:20 and a transit time of 2 hours 30 minutes, what is my ETA?
$10.50. Oh.
Yep.
I was doing it in my head. Yeah.
There you go. Yeah. 10:50. So I think I'm going to be here. I'm going to make a little DR at 10:50. But then I want to plot my DRs along the way. I'll wait for a minute so you guys can catch up. Do you guys follow this one along? How I got the 16.2? We had to measure it. The 6.5 was given to us in the problem. So I did my 60 D street to figure out transit time. Then I applied it to my departure time and got an ETA. Okay. So now I want to plot my DRs along the way. So again, I like to do it on the top of the hour and then every hour after that for a certain leg. So if we depart here at 8:20, my next time would be 9 o'clock, right? That would be the top of the hour. So I want to plot my 0900 DR. So how I'm going to do this is get my time, right? We need our D, our S, and our T. So my speed is 6.5 knots. And my time, I want to figure out, I put my later time on top, 08:20. You can do it the long way here, or do it in your head. 40 minutes. So my time is going to be 40 minutes. What is my distance? What did you guys get for distance?
4.3 nautical miles.
Okay. 4.3 nautical miles. So then I'm going to use my dividers and measure 4.3 nautical miles. I wonder if I can. I can't get it over. Okay, so I have my 4.3 on my dividers. Start at Breton Reef. I'm going to put a dot right here with the semicircle. Say this is where I think I'll be at 0900.
Do you ever mark the distance also on there? And if so, how would you write it?
If you're doing distance, you typically only write distance for the entire leg, where I would put a DIST or just a D. And you put it for the entire leg. The reason you're putting a DR is the distance. It's kind of a visual of what that is. I guess. That's my answer
You
to
put a
that.
circle around it?
It's a half circle. So it's like that.
So is that a symbol for the fix? And is that considered a dead reckoning symbol then?
Correct. This is a symbol for a DR, and that would be our DR fix. It's because we had a known position, a course, and a speed, and a time.
Mm-hmm.
So do we add 20 from there, basically, along the line?
Add 20?
Or add 20 to 0900?
I don't know why you would add 20.
Because you, sorry, I think it's 40 actually. Yeah, it's 40. 40 minutes for each.
So you combine them.
This is 40 minutes.
Yeah.
And then from here, we're going to do every hour. So we're going to do 60 minutes. And that's going to be really easy because we have a speed of 6.5 knots. And what is a knot? Nautical mile per hour.
Oh, okay.
So all we have to do is get 6.5 on our dividers, and then we could plot where we're going to be each hour for the remainder. So I'm going to get 6.5 on my dividers. I have my monitor in the way, so I can't move my camera all the way to the side. Tried to get the biggest desk I could at IKEA, but there's always something. So here's 6.5. So that's where I think I'll be at 10. And where will I be at 11? Just past my destination here. So being there, my ETA I had guessed at 10:50. So that makes sense, right? It's pretty close to 10:50 if I'm visualizing the time travel here. I don't know. As a little boat goes along. Okay, so that's 1 through 5. Any questions with plotting our DRs so far?
Hey, Bree, it's Lisa.
Yeah.
So when you plotted your 10 o'clock, you did it from your 9 o'clock DR. You never go back to the beginning. You never go from 8:20 to, you always start at your last dead reckoning plot.
You can go either way. The reason why I plotted it from my 9 was so that it would be quick, easy math. Just use 6.5, and I wouldn't have to do 60 D Street for an hour and 40 minutes.
Okay.
So it just kind of is a quicker shortcut, I guess.
Yeah, no, that makes sense.
Okay. So then I'm going to move on to number 6. So we were at the light at 8:20. And we think we're going to be here at 10:50. We have an 0900 and a clock DR. Just trying to simplify it on the whiteboard here. So then it tells us that we actually arrive. So this is an actual fix. And then we actually arrive here at 10:35. What was our speed? Question. So just by looking at this, I thought my speed was going to be 6.5, right? I had a course of 0.96 and a speed of 6.5. Am I going faster or slower than 6.5?
Faster.
Faster, yes. So with our calculations, we should be calculating a speed that is more than 6.5. So just keep that in the back of your head. So to calculate speed, we need a distance and a time and a speed. We're looking for speed. What is our time? We have 8:20 and 10:35. So we need to get the difference between these two times to see how many minutes has elapsed. So I put the later time on top, 10:35 minus 08:20. So I have 35 minus 20 gives me 15. 10 minus 8 gives me 2. So I have 2 hours and 15 minutes. I need to convert that to minutes. So I have 120 plus 15 gives me 135 minutes. So I can put 135 minutes. And then what was my distance? I wrote it down here on the chart. My distance was 16.2. So now I can use my 60 B Street magic circle. Let's see, I'll use my magic circle this time. $60 times 16.2. Looking for speed. My time was 135. So I'm doing 60 times 16.2 divide by 135. And what do you guys get for speed?
7.2 knots.
7.2, and that checks out. It is faster than our 6.5. So if I thought I'd have the same current and the same everything else going forward, then I might change my ETAs to this new speed. Or maybe I'm going to adjust my speed from here. Did that make sense? Okay. Okay, so next part of the problem or the question, we take photos and we fish, have a little lunch, whatever, around Gay Head Tower or around Buzzard's Light. And then we depart Buzzard's Light at 10:56. And we plot a course for buoy 29 off of Gay Head Light. So what is this course? Let's plot it. Okay. So buoy 29 is here right off of Gay Head. So I plot my course. And I want to know what that true course is. So we're going to use one of our nav tools to measure it. Using the triangle. You can measure it there. Roll plotter, you're right next to a compass. So you just bring it on down. What course did you guys get?
103.
3.
Course of 103 degrees true. Okay. And it tells us our speed. We have a new speed of 5.6. So we slowed down. We're slowing down. Locate this buoy and plot the course. Okay. And then it says, okay, what is our ETA? So we want to figure out the length of this new course. I don't know if your dividers will reach. Mine do. What's your guys' distance?
Right between 7.9 and 8.
Oh, I got 7.9. So if we have a estimated departure time, a speed, and a distance, we can now calculate our ETA. So we have a distance of 7.9 a speed of 5.6. I'm looking for my ETA, so I'm looking for time. So let's do 60 times D divided by S gives me T. What do we get for T?
Hour 25.
An hour and 25. Times 7.9 divided by 5.6. That was, yeah, 85 minutes or an hour 25. Then we apply it to our departure time, not estimated. We departed at 10:56. Our transit was 1 hour 25 minutes. What is our ETA?
12:21.
Sounds about right. So we have 56 plus 25. $56 plus 25 gives us 81. We can't have 81, so we subtract 60 and we get 21. So we subtracted 60 and carried that 1 up here. Then we have 10 plus the 1 and then the other 1, and we get 12:21. I'm going to be right back for a second. My dog's going crazy. Bobby. Any questions with that so far? Making sense? Okay. I'm going to erase this part. So they told us we actually arrived at buoy 29 at 12. So we thought our ETA, what do we say? If I was plotting it as a DR, we thought we'd be there at 12:21, but we actually got here at 12:15. What was our actual speed? So again, we see what we have. We're looking for speed. Our distance is our 7.9. And our time is going to be between our departure time and our arrival time. So we put the later time on top, 12:15 minus 10:56. We're gonna do the minute side first. 15 minus 56. I can't do that. I have to borrow. So I'm going to borrow and make that an 11 and add 60 minutes to my 15. So I'm going to make this 75 minutes. So now I have 75 minus 56 gives me 19. And then I have 11 minus 10 gives me 1 hour. So I have 1 hour and 19 minutes, but I need to convert that into minutes because this is 1 hour, 19 minutes, but what is it in minutes? I need to add my 60 and I get 79 minutes. So now I can plug it in. Let's do magic circle. So I am multiplying 60 times 7.9 divided by 79 gives me a speed. My speed is equal to 6 knots. All right. Guys following along so far? Any questions? Am I going too fast? Okay. Okay, I'm going to move my camera. We're going to go into Martha's Vineyard. Okay, so the next part says to finish the trip, label and lay a course to buoy 1 at the entrance of this pond. I'm not good at pronouncing all of these different places, but we're looking at this black buoy right here. It's really hard to see, but there is a number 1. It says 1 bell, but it is hard to see. There's a 1 right there. Excuse me. So I'm going to plot my course. Okay, so I want to get what the course is and ETA, my course and ETA. It says my speed is 5.6. So I'm gonna have put in my course, put in my speed, 5.6, and my course, I'm going to measure. I'll use the triangle because I think you guys can see that this time. So I have the black line on my course, the focal point on the vertical line, and then I'm going to read at the top. For me, it goes right over 0.95, a little bit closer to 0.96. Kind of right in the middle for me. So I'm going to write 0.95 degrees true. My speed was 5.6. And I got to, I didn't write it on here, I got to my buoy 29 at 12:15. Here. So, excuse me. I want to figure out what my ETA is. So I have a speed, distance, time. My speed is 5.6. Excuse me. Knots. My distance I need to measure. What do you guys get for distance?
46 minutes?
4.2.
4.2.
Distance.
4.2 nautical miles. I could write that on here. Distance, 4.2 nautical miles. It's getting a little congested there. And I need to figure out time. So let's do 60 times D divided by S equals time. 60 times 4.2 divided by 5.6 is time. Let's do 60 times. 45 minutes.
So 13 o'clock.
So 1300.
1500.
1300. So we had our 12:15 plus our 45 gives us 13 o'clock.
I still have to fight not putting the colon in there.
Yeah, Yep.
Bad American. I just wish everything was decimals. Life would be so much easier. My job would be so much easier. Converting units.
Well, yeah, today's all about units. You can share that with your class.
Oh, I share everything we do with my class. Even as a student, I'm like, look, I just like you guys, I get behind once in a while and have to go back and watch the video and have to do my homework, practice.
Yep. So our last question is practicing time. What was your total time elapsed between Brenton Reef was at 8:20 and our Memesha Pond was at 1300. So how much time has elapsed?
4 hours, 40 minutes.
4 hours and 40 minutes. We want to put our 13 on the top. 0820. Borrow from the 13, so I make that 12 and make this 60. 60 minus 20 is 40. 12 minus 8 is 4. Okay, so we got through our plotting assignment today. Yay, maybe we had better time management on my part. But definitely practice your 60D street. I think assignment 9 has 10 questions practicing your 60D street, so work on that. And next week, we are going to be looking at LOPs. So we are going to kind of be putting what we did last week, our compass error, and then adding our 60D street and LOPs into next week, where we're going to be doing both the 1210 TR and the Long Beach San Pedro channel chart as well. So yeah, it's basically a lot of plotting next week. We're going to kind of put everything that our little building blocks that we've learned here over the last 4 weeks and put it into some plotting exercises. So are you guys feeling okay about what we've been practicing so far? Okay, cool.
Just a little more practice.
Yep, practice, 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 always.
Need to get up to speed.
And yeah, feel free to, email me. We could set up a Zoom or whatever sometime during the week. I am available. Yeah, we only have two more weeks of new information, and then we kind of review everything in the last week. So seems to be flying by. For those of you who are interested in CoNav1, we're going to be doing more set and drift. So I do suggest getting radar plotting sheets. We use that for some of those exercises. You could get them on Amazon. You could also get them, you can get like, a pack of like 300 or 500 at Amazon, or you could get them for like 10 cents at the store at OCC. So I don't like to be like, oh, you have to get them next week. So if you're going to take CoNav1, you have like 3 or 4 weeks to get some radar plotting sheets. You probably only need like 3 or 4. You don't need 500. When I teach the class in person, I just hand them out to you guys because I have the 500 pack. But it's one of those things with distance learning that you have to get it on your own. So, yeah.
3 is Coastal Navigation 2 going to be in person by chance?
No, it's going to be distant. I guess there are more and more classes in person. They're doing them like outdoors, but there's not great lighting. I don't know. To do night classes out there seems challenging.
It's cold. I think there's probably too many people in this class for them to do it.
Yeah,
indoor.
that's the other crazy part. Like, I think my max was like 15 before.
Yeah.
Because there wasn't even desk space available, and we have 27 in this class.
Yeah,
So,
they've opened up classroom 1 and classroom 2 and to combine, so you can get a lot of circulation through, but then they're only putting a very few people in that. So I don't think that they would do that. Is it going to be the same day of the week and time?
yes.
Okay.
And it just following this, no break, just week 7, and then we go to week 1 at Coastal Nav 2. If you guys.
Yeah, it conflicts with the U.S. Coast Guard class that they're offering.
Yeah. Is that Monday, Wednesday, Friday, or every day of the week?
Monday, Wednesday, Friday.
Monday, Wednesday, Friday. They should make this class like Tuesday or Thursday then, because that always happens. I don't know. Well, for those of you guys taking that class, if you get stuck on something, get my contact information. Happy to help. The more mariners out there, the better.
How many people in this class are taking that class?
I'm doing it.
Who was that?
Jacob.
Jacob, and I know Billy and I are both doing it. Billy, are you doing the next one?
What was that, Colleen?
You're doing the next one, right? The one that starts this month?
Not sure yet.
Might do Coastal Navigation too before I do the U.S. Coast Guard.
Hey, Lisa, are we taking 2?
Oh, Aaron's got a plotting sheet there. That works.
Right, so that's a radar.
There we go.
I want to ask the difference.
And that's the universal plotting sheet.
Can we use that?
Yes. We use that one for Celestial if you take the CNAV class with me.
So that's Celestial.
Hey,
also,
Bree, can I ask you a question? This is Rob.
Yeah, go ahead.
Just a quick one. So they discontinued Loran C back in the a few years ago. I hear they're going to start up eLoran. Is that do you know what the timeline is on eLoran? I guess they're a little bit nervous that GPS wasn't quite as bulletproof as they thought. Do you have any timelines on eLoran?
I do not. I have not heard that. I'll have to look up some articles. I don't know. That would be
I guess
interesting.
the Indians shot down one of the GPS satellites, so they decided the GPS wasn't quite so bulletproof. They needed a backup system now.
I can see that. That's the fear of electronic navigation, is that it's hackable, and
yeah,
there's all sorts of conspiracy theories out there.
Do you think they'll use the same stations for eLoran as they did for Loran C?
I don't know how that
They
would
already
work.
have them.
I am not
Seems
sure.
like they've already got them.
Yeah. I don't know.
Okay.
I felt like I was going to say something before. I don't know. Something about Coastal Nav 2. Oh, radar plotting sheets. If you can't find them and you can't get into OCC, I do have a printable version on the Google Classroom, but it is just condensed and smaller. sometimes they're easier to use when they're actually on the regular paper. But again, it's just 1 week, so don't stress about it at all. I did want to mention on this, for this week, I have extra 60D Street practice problems put on the Google Classroom. So I think it's at like the top. There's 2 different worksheets on 60D Street. So you have the one assignment 9, and then if you really want to practice, you can look at those worksheets too. I think those worksheets actually have a few different units in there as well, if you wanted to practice that. So that's all I got for you guys. Any questions? You guys doing good? All right. Well, have a good weekend, and I'll see you next week.
Thank you.
See you guys.
Okay, Roger. Over and out.
Everyone.
Thank you.
Hey, Bree, before you sign off.
Yeah.
So this is on the deviation table. I don't know why I can't read this table, but a compass heading and a magnetic heading seem like the same thing to me.
So that's because we like to say magnetic compass.
Yeah.
So it's kind of like what we were talking about, how we said like nautical mile and mile. That your magnetic is where the magnetic North Pole is. That's what that's based off of. And then,
right.
So let's.
But the compass on your boat is based off magnetic north. Right?
It's based on, oh, dang it. It's based on, okay, so I kind of look at it as layers. So here is true.
Yeah.
Lining it up with the chart here, right? So if I had my boat cruising along this direction, I want to see what it's going true. So it'd be like 135 true.
Yep.
I'm going to put on my magnetic compass. So this is the variation. So the variation says the magnetic North Pole is, what do we have? We have, on this case, we have 15 degrees west. So our magnetic North Pole is to the west.
Right.
Right? So if I have my boat still headed in the same direction, so it's not affecting what my boat is doing. But if I was doing 135 true, my 135 is over here. So I would have to add whatever my variation is to get what this magnetic reading is.
Yes.
So that's where the direction of the magnetic North Pole is. But I'm going to add on top of that my compass, because instead of being exactly lined up with the magnetic North Pole, it's getting pulled one way or the other because of my boat's magnetism. Because of my boat pulling, you know, the magnetism of the mast or whatever, the engines pulling this away from magnetic north one way or the other.
Yeah, I understand that.
So let's just keep going to the west here. So if I keep my boat at 135 true, right? It hasn't changed.
Yeah.
My 135 is further and further away from, you know, this 135 because we keep adding our error, our westerly error.
Yeah, and maybe my question is even simpler than this. I understand that.
Okay.